Okay, 5-5. I'm going to title this Sides, Angles, and Diagonals. And we're talking about these quadrilaterals for the rest of the chapter, the 7 that are listed up here. It's really important that you know how they kind of relate to each other. The fact that the parallelogram is kind of the most general. Okay, the rectangle and the rhombus are kind of both looking at a parallelogram but in a different fashion. A square is the child of these two. A kite is neither a parallelogram, but much like a parallelogram is related to a rhombus, so a kite is related to a rhombus. And then the last two, the two strange, the trapezoid and the isosceles trapezoid, are kind of in their own little sphere. All right, characteristics of these are really important for section 6. Here we go. 5-5, properties of parallelograms. First of all, know that there is a definition. Opposite sides are parallel. That's the definition. So I don't really consider that to be a characteristic because to me that would need to be different. In each of these cases, you probably could come up with most of these on your own if you just think sad thoughts. Sides, angles, diagonals. Okay? So again, how does this side relate to that side? How does this side relate to that side? How does the angles relate to each other? Right? How are the diagonals related to the sides, related to the angles, and related to each other? So this is by far the more novel piece, so to speak. How do the diagonals, what do they do for us? Here we go. For a parallelogram, the opposite sides are not only parallel, but they are also congruent. And the opposite angles are congruent. And the diagonals bisect each other. Okay, so they cut each other in half into two equal pieces. Note this piece is not equal to the other two pieces that the other one is. And consecutive angles are, this is probably the least obvious, supplementary. You've seen this in a couple of problems, and if you recall parallel lines cut by a transversal, you can see that if we have, again, two parallel lines cut by a transversal, then these two angles, call them 1 and 2, have to be supplementary. And for example, if you looked at 3 and 1, it too would have to be supplementary. All right, parallelogram, one of the most basic shapes. Now, as we look at the next things below that, know that we inherit all this stuff. So all the parallelogram stuff from above applies to a rectangle. First of all, let's do the definition. One angle is 90 degrees. And again, you can think of that as at least one angle, right? Because as soon as you get 190, you get them all to be 90, right? As soon as this one is 90, not too obvious in pink is that. As soon as you get this one 90, then this one has to be 90 because it's opposite, and then this one has to be 90 because they're supplementary. So all angles are 90 degrees. That would be item number, first characteristic of rectangles. And the diagonals are congruent. So not only do they bisect, but in this case, the diagonals are congruent. All right. Kite. Again, kite is kind of strange. We don't have those opposite sides. So here it's more about the diagonals than anything else. But do notice, yes, that these two angles are congruent to each other. This angle here is not congruent to this angle here. right? They're different. But those other angles, y and w, if we want to call them that, they are bisected, okay? So 1 is congruent to 2, and 3 is congruent to 4. Not so in my other angles. First of all, what is the definition of a kite? It's two pairs of, fancy word from the last section, disjoint. Sides are congruent. Okay? The diagonals now are property. The diagonals are perpendicular. One diagonal is bisected by the other. And then the other diagonal bisects the opposite angles. Okay? So again, that idea that, if I can erase this here, this, gotta go to blue, this is congruent to that. It's been bisected. Now clearly we can see that these two segments aren't congruent, but we do see that the other diagonal then bisects, again, those angles, correct? All right. And finally, one pair of opposite angles are congruent. One thing that the book fails to mention is because there's perpendicular, we also end up with 4 right triangles here. Oop. So we get a right triangle here, right triangle here, yeah? And because they're perpendicular, then we obviously end up with those. And those come into play in lots of problems, now and in future chapters. Rhombus. All sides, again, this is the definition, all sides are congruent. All right, so that's what makes a rhombus a rhombus. So it's a parallelogram with 4 congruent sides. So all the parallelogram stuff we inherit, yeah? And then we also inherit all the kite stuff. So I draw a kite and I draw a parallelogram because a rhombus has both those features. So as we look at the new thing here, not too much about the sides of the angles. That's new, right? Except that if you look at the angles now, or excuse me, the diagonals now do kind of nifty things. For example, they bisect. Okay, diagonals are perpendicular bisectors of each other. And they also bisect the angles. Okay? And these are the angles at the vertices. Finally, again, if we look on the interior here, we create 4 congruent, and these happen to be right angles as well. Okay? Diagonals create 4 right, congruent right triangles. Nothing new with a square, except one additional thing, because now we get all the things that we had with the rhombus. I guess I should draw the rhombus. Let's draw a rhombus kind of like a diamond. I'll make it more rhombic. And again, if we go back to original diagram, remember we get the from the rectangle and the rhombus. So we inherited all the parallelogram stuff, but we also get the rectangle stuff, which is the angles. So all the sides, all the angles. And again, the diagonals create 4 congruent right isosceles triangles. So these we've got the right angle, and these also are now congruent to those. Okay? Finally, we end up with the trapezoids. The legs for the isosceles trapezoids, yes? Caution. So legs are congruent, and there's only one pair, and the bases are congruent. Again, that is the other pair. The lower base angles then are congruent. All right, so if we come over and look at the diagram, we see that the lower base angles, as well as the upper base angles, are congruent. Diagonals are congruent, oddly enough, right? That distance and that distance are the same. Not so in a regular trapezoid, right? One could be longer. And the one property of trapezoids, and that is that the base, how do I want to say this? This angle here call it 1, and this angle here are supplementary. All right, so we have consecutive angles with the bases and the legs as being supplementary. So this is 3 and this is 4. Okay, so base angles, one lower and one upper are supplementary. All right. Here we now have a triangle. We'll go through a problem and a proof. And it's not drawn for us. So it's real important that we sketch this out in our brain, actually on paper. So sketch out a parallelogram. Oops, I shouldn't be drawing a rectangle. So here goes a parallelogram. And we need to label it. Again, we should start somewhere with Z. Doesn't matter where, but then go clockwise around or counterclockwise, doesn't matter. And now we know the different sides. So this is 2x minus 4. And our z is 1/2 x plus 8. These two sides might end up being shorter just because we have put them on the wrong pair. But that's okay because that can just be a perspective issue. All right? And then now we can set our different things equal to each other. So our expressions, right? That equals that. So y plus 12 equals 3y plus 5. And likewise, 2x plus 4 minus 4 equals 1/2 x plus 8. I'm not going to spend time solving the algebra of those two problems because they're not difficult to solve. All right? Finally, if you're given a problem and they don't give you the drawing, you need to create the drawing. This one is a little bit trickier because even though I'm going to go the opposite way this time, MPRS, that is not tough to draw, but where the heck is O, right? MO to PO. Like O could be here, it could be here, it could be here, and it's important to get these spots down, right? Any of these places that make it equal distant. Try not to pick something that's near the center because that's like a really special spot. So I'm going to pick something really close to the edge, and it doesn't really matter if it's inside or outside because it should hold true. So notice those two distances are congruent, it says. And we have to show that triangle ROS is isosceles. So my goal is show this is congruent to that, or this angle is congruent to that angle. Okay? Either one would get me that there. So I think the first stages is always important to do some planning before you dive into the proof. In this case here, hopefully you're looking for triangles. I think it's a good strategy. Works 90% of the time. And so I first of all started looking at this triangle. It's only one triangle, and it's not really congruent to anything else. I was going to think about splitting it in half, but that seems like a lot of work. So then I noticed that there were these triangles, and they look like they might be congruent, and furthermore, they share stuff with the given and stuff with the proof. So those two triangles there look really promising. If I could show that they're congruent, then I could get those sides, OS and OR, congruent. All right, well, let's try to think about why those two triangles would be congruent. So we've got a pair of sides. I think a rectangle has a property that this side is congruent to that side because it happens to be a parallelogram, and parallelograms have that property. Do we have an angle in between, right? Is this angle congruent to this angle? Rubbing my chin for a little bit, wondering what could that be? And I don't immediately see it, but then it dawns on me, I do know that these angles are congruent. And I do know that these angles plus those angles would give me 90 degrees. So here I think the exterior angles, you could call them 1 and 2. They're not actually exterior, but they're outside of triangle mop, okay? They are congruent to those inner base angles of that isosceles, okay? By the complementary theorem, okay? So I think this is probably like a 6 or 7 line proof. We've got our given, we've got line 2, we've got angle. Again, we probably want to, call that 3 and 4. So angle 3 is congruent to angle 4, and that's because of base angles are congruent when the sides are congruent of a triangle. And if 3 and 4 are congruent, then we know that 1 and 2 are congruent. And again, the justification there is because if two angles are complementary to congruent angles, then they are congruent. So I believe we call that complements of congruence theorem. Write that out because that's probably one that we haven't written out for a while. Complements of congruence theorem. Almost done. MS is congruent to PR. This one I'm going to write out too because it is a property. So this is a property of parallelograms. And that's sufficient, okay? Opposite sides are congruent in a parallelogram. 5. I think now we have triangle POR is congruent to triangle MOR. And that looks like the side angle side theorem. Finally, line 6, SO is congruent to RO by our famous CPCTC. And line 7, we're there, I think. Triangle ROS is isosceles. And that is by definition of isosceles triangles. All right. Hopefully that helps get you through the lesson, all the different characteristics of those quadrilaterals. A lot of notes there. Hopefully you got them all down.